I'll display the tree view and list view control form. And this displays on the left a tree view and on the right a list view control. On the left I have a list of all my drives with plus signs next to them. If I expand one of these, that turns to a minus, of course, because there are things in here. For any folder where there isn't anything, clicking the plus sign will just attempt to open the folder, but actually remove the plus sign if there's nothing in there. But for now, let's go find a folder where we can explore some actual files. There we go. And we'll see in the debug folder there we have some files. And for each file, we see an icon that describes that file. It doesn't appear to be the correct icon, but close enough. And over here on the right-hand side, we see size and date modified. Within this list, we can sort the items ascending and descending by clicking on the column headers. If I double-click a file here, it should attempt to execute that file. And in this case, it loaded the file up in Visual Studio. Let's go back to our example here. And we should also be able to right-click on the list view and change its display. Here's large icon view, details view, small icon view, list view, and tile view, which is not terribly attractive because I just haven't done the work to make it look better than this. We can also group the file names. So let's go back to details view and group the file names. Unfortunately, they all begin with A, so it's not very meaningful, but you could see they would be grouped alphabetically by the first letter of the file name if I had chosen a folder with groups of letters other than just A. If we ungroup again, now things are back the way they were. There are a number of various properties that affect the way the tree view control appears. For example, we could show checkboxes next to every item. There's a checkboxes property. There's a hide selection property, which gets or sets a value indicating whether the selected tree node remains highlighted even when we move the focus away. Right now, hide selection is not set to true because we maintain the same selection. There's an indent property, which affects how far in the child nodes appear. There's a label edit property, which gets or sets a value indicating whether the label text of tree nodes can be edited. Well, right now, I haven't allowed editing, so I've set that to false. There's a line color property, which affects the color of the lines. There's a show lines property, which gets or sets a value indicating whether the lines are drawn between the tree nodes. Those could be turned off. There's show node tooltips, which gets or sets a value indicating whether to show a tooltip. For now, I've turned it on, so if I hover over a file and part of the file isn't showing, we can still see what the full name of that file is. It's a useful thing to do when you have a split container control and you want to make sure you can see all the data. There's a show plus minus property, which indicates whether or not you want to see these pluses and minuses here. And there's a show root lines property, which gets or sets a value indicating whether lines are drawn between the tree nodes that are at the root of the tree view. We see right now we have 3 nodes at the root, and they have lines between them because the show root lines property is set to true. Now that you've seen the form in action, we need to investigate how it does its job. Let me stop running for now. There we go. And let's look at the source code for this form. Here's the sample form in Design View, and it's a split container that contains on the left-hand side a tree view, on the right-hand side a list view control. Here, if we want to look at the code for this thing, we'll start by finding the fill drives procedure. The fill drives procedure starts by looping through all the drives in the getDrives method of the DriveInfo class, and for each one of them, we set the key to be the word drive, set the name to be the name of the drive, and if the drive name ends with a backslash, we remove the backslash. Now we have a procedure here to get the image key for the drive. Let's go see what that's doing. getImageKey determines what kind of drive it is, and based on the kind of drive, it sets the key to be a specific type of drive, so we can display the correct image later on. Let's go back to the fill drives procedure. There it is. So we got the key here, and now we'll add a node to the nodes collection of the folders tree view using the name of the item, which in this case is the drive name, using the same name here as the text. We set the key to be the drive name, the text to be the drive name, the image index to be the key, and the selected image index to be the key, which means you can have a different index into a list of images for the node when it's not selected and when it is selected. Now we'll also add a child node to our new node named filler so that we see a plus sign. If we don't add that child node, we won't see the plus sign next to the drive letter. What would be the point of not having a plus sign? That way users wouldn't know they could expand the drive to see all the folders and files on that drive. When you expand any node in the tree view, the before expand event occurs. Let's find that. Here in the before expand event is the code we run when you expand any node. We start by first getting a reference to the node you just expanded and storing it away into a variable. We clear all the child nodes of the current node, which removes that filler node and therefore removes the plus sign next to this node. Now we go through all the folders. To do that, we get the full path of the current node. Remember, we could be several levels deep in the hierarchy. The full path property returns the full path following from the beginning all the way to the current node concatenated together, which gives us the full path of the folder we clicked on. Given that, we call fixPath. This procedure just ensures that we have something that ends with a backslash. Let's go back to where we were. So we've fixed up the path. It ends in a backslash. And now for each folder that we find in the folders contained within the current folder, what we do is for each folder we get the file name part of it. We're going to add a new node to our current node. We'll use the file name as the key. The file name is the name because we know that's unique. We can use it as the key. We also have stored away images for closed folders and for open folders. Just a different image, so when it's selected and when it's not. We add the child filler node, so again we get a plus sign next to our new node, and we set the tooltip text of our new node to be the full path of the new node. So if you hover over it, you see the full path of that node, even if part of it is obscured by the separator between the two panels. That's all we need to say about the tree view for right now. Let's look at the list view control. Our list view control has certainly a number of columns. It also has views. There's details view, large icon view, list view, small icon view, and tile view. You saw all of those in the previous demonstration. You also saw earlier how you can group the names within the list view control, and that view is only available on Windows XP, Windows Vista, and Windows Server 2003 or later, and requires that your application has its application.enable visual styles method set to true. That's the default behavior. Visual Studio adds that for you, so you don't generally need to even worry about it. But if you change it, you need to be aware that the list view's grouping may not work. Let's start by looking at how we work with images in this control. There are two image list controls on the form. The first one displays our normal set of images, and the second one, although you can't tell here, would be for large images. In addition, you can add as many different sets of images as you like, so you can change the way things look within the list view control. There is a place where we'll need to add images to the large images image list control. There's nothing in it right now. We add these items later. So let's look for the code for that, which is the add icon to image list method. There it is. Given a file name, we're going to add its icon to the image list if its icon isn't already there. This makes it so we don't have to go get icons for every different application. Instead, we store away the icons we've used and always look there first for a file's icon. So the first thing we do is get the extension for a file, and if it's null or empty, well, we're done. There's nothing to really be done here. But if our images collection doesn't already contain something for that extension, then we use the system.drawing.icon.extract_associated_icon method given the file name. That hands us back an icon. We're going to add it to the images property of our large images collection and our images collection. So we've added it to both, so we have it both for small and for large images. We have this icon available to us. Later, we'll use this in the list view control to display the icon for the specific file. Let's look at the fill files procedure, which fills in the list view control information about the currently selected tree node. Okay, so what do? First thing we do is clear all the items in our list view control. Now we need to iterate through each file in the folder that's represented by the TreeView node. We do that by using a for each loop, going through all the files returned by the getFiles method. For each file we get, we create a new file info object. Given the file, we call that add icon to image list procedure we just saw. So now we should have an icon for the selected file type in our image list. For each file we found, we'll create a new list view item. And when you create a new list view item, you specify here, let's see what the tooltip tells us. You specify, well, there's a lot of different overloads here. We're specifying the name and the key for the image we'd like to display. The name of the file will be the title of the item in the list view, and the ext tells us which image we should use. Now, each item in a list view can have sub-items. The way a list view control works is the item displays in the first column. Everything after that is sub-item information. So here, the name of the file is the item, and then we add sub-items to that list view item. We'll add here the length, formatted as a number with 0 decimal places. We'll take the last write time and add it also to the list view. Then we'll take our list view, add to its items collection our new list view item and all its sub-items. There's only 2 sub-items, but it would add as many as we had. Now, if we're showing groups at this point, we're going to set groups based on the 0th column. Now, of course, you could group on other columns. We're just not at this point. Let's look at the set groups procedure. The set groups procedure is rather complicated. What the set groups procedure has to do is go through and create a list of all the different groups and then place things in the correct group. So the first thing we do is clear the groups collection of the file list view control. Now the groups we're going to create is a generic list of string. We haven't talked about generics here, but it's pretty clear what we're doing is creating a data structure that can only contain strings within it. We'll iterate through all the items in the file list view control. Look in the items collection. For each one of them, we're going to get the first letter of the item's text property. That's the name of the file. Convert it to uppercase and store that away in a group name variable. If our groups collection already contains that group name, then we just retrieve a reference to that existing group. If it doesn't already exist, we add it to our list of groups. So say this is the first file we found that begins with a T. Since T wasn't already in the list of groups, we add it to 2 places. We add it to our own list of groups, and we would add it to the groups in the list view control. So we're using our generic list of groups here to keep track of whether something already exists or not. Because the groups collection provided by the list view doesn't give us an easy way to determine if an item is already in the list. That's why we're using our generic list of strings, named groups, to check to see if it already contains a particular group name. If it does, we retrieve the corresponding group from the list view. If it doesn't, we add it to our own group so we can check for it next time. And we also add it to the list of groups in the list view control. So if we had a file that began with T, we would now have a group named T for the list view control. When I then show the list view control in the grouped mode, because I have a group named T, any file that begins with T would appear within that group. So by creating the groups, when I then ask the list view to do its grouping, it knows where to put each item within the list view control. Sorting the items in a list view control is harder than you might think. The sort method only sorts on that first column, the items within the list view control. If you want to sort on something else, you're going to have to do a little extra work. I want to be able to sort on any column by clicking on the title, and to do that, I need some other classes. I need a list view date sorter, a list view size sorter, and I can even, if I want, supply my own string sorter to get strings sorted a certain way. Let's look at one of these, say the date sorter. The list view date sorter is a class that has to implement the iComparer interface. The iComparer interface requires you to supply a compare procedure which compares two objects of the correct type. In this case, we're passed in two objects, and I'm given actually two list view items that I'll compare. In this case, I want to cast those items as list view items, get the values I care about, and in this case, you'll see I have a variable call into which the constructor for this class has placed a value it's been sent. So here, for example, if I want to sort on a column that is column 2, and I want to sort in descending order, I would have 2 here and a value indicating descending here. I store those away into these private variables. Then when it comes time to sort, here I would retrieve the value from the specified column, convert it to a date, and put it into date value. We compare the two items by comparing the two dates. The way you do that is by saying the value 1 dot compare to value 2 gives me a result. It's this result I care about as long as I'm not sorting descending. If I'm sorting descending, I have to return the negative of that value. So I assume my factor is 1. If I'm sorting descending, I set the factor to -1, and I return factor times result. Either a positive number, a negative number, or 0 if the two values were equal. Let's finish this tour of complex controls by looking at the month calendar and date time picker controls. Both controls provide a visual interface for selecting dates. Each provides its own set of unique capabilities. The date time picker allows you to select a date or enter a date or time. The month calendar displays 1 to 12 consecutive month calendars and allows you to select a single date, select a range of dates, or bold annual, monthly, or individual dates. Let's look at an example that shows off features of these controls. I'll load the month calendar demonstration form, which allows us to play with various properties of the month calendar control, which you see at the top of this form. Let's start by limiting input dates. By default, the range of valid dates is January 1st, 1753 to 12/31/9998. For some reason, those are the dates they've picked. You might want to restrict those dates. You can, for example, change this. Let me pick some other date. It could take a long time to get where I want to go. Maybe I can just type it in here. There we go. Now I've limited so the maximum date I can select is January 31st, 2008. I can't go to the right of there. I can go to the left, but I can't pick anything bigger than January 31st, 2008. So you can use that to control the behavior of the range of dates that are allowable on your calendar. You can set the first day of the week. The default is set by your operating system for the current locale, but you can override that behavior and select the first day of the week that you want on your calendar. In my locale, Sunday is the first day of the week. You can format the control. The month calendar control has lots of ways to format it. For example, I can set the back color property. Now, I will warn you that it works for me, but it might not work for you. Your operating system and its themes can remove the ability to format the calendar. If you're using Windows Vista with the arrow theme, for example, none of these work. You can change them all you like, they just don't do anything. This is documented. It's in the documentation. Just want to warn you that if you try to change these values and they don't work for you, it's because you're using a theme which overrides that behavior. You can display from 1 to 12 consecutive month calendars using the month calendar control. The calendar dimensions property, which is a size structure, that is, you set the width and the height, controls the number of rows and columns. So if I want to, for example, have 2 columns or 3 columns or 2 rows, you can see I can scroll down now and I have 2 rows worth of calendars in there. Now I have 1 row of calendars in there, and I can reduce this back down as well. The interesting part is if I select a value that's out of range, like 5 by 3, the calendar control will reset it to a valid setting using a best fit scenario. By default, the month calendar control allows you to select up to 7 consecutive dates. I come in here and select up to 7 dates, but no more. There I've selected 2. You can set this value to anything greater than 0. Set it to 1 to allow only single dates, or you can make it bigger and you can select a large range of values. I display all the dates we selected. I display all the selected dates by looping through the selection start through the selection end properties of the calendar control. Selection start gives me the first day. Selection end gives me the end date. I'm looping through them all and displaying them there in that message box. You can also bold dates. To bold dates, we can call the Add Annually Bolded Date, or Remove Annually Bolded Date, or Add Monthly Bolded Date, or Remove Monthly Bolded Date. We can call the Add Bolded Date, or Remove Bolded Date to get a single date bolded. We can also call the Remove All Monthly Bolded Dates, or Remove All Bolded Dates. There's lots of methods here dealing with bolded dates, but they're very simple to use. Here, I'll make Valentine's Day bold, so we get in each year, we get February 14th bolded. If I uncheck it, we remove yearly bolded dates. I can make the first of each month bolded. And now I can scroll through and you'll see that the first of each month is bold. It's hard to see because it keeps highlighting it, but it is bold. If I uncheck it, it removes that. I can make May 16th of 2009, just a date there. Let's go see if it's bold. Yep, that one date is bolded. So you can bold yearly dates, monthly dates, or single dates. In addition, you can clear all bolded dates, and if I make first of each month bold and display all bolded dates, you'll see I have no non-recurring dates. I have 1 monthly recurring date that begins then, and I have no yearly recurring dates. There are methods that let you retrieve the recurring dates from the month calendar control. Well, you've seen here pretty much what we can do. Oh, there's a little bit more. We can show or hide today. Can't see it because it's off the bottom, but there it is. You can show or hide that. We can show or hide the today circle. Where's today? Well, let me go back to today. If we show today's circle, there it is. It's not really a circle. I guess it used to be a circle, not anymore. And we can show week numbers if you like, and those show up on the left of the calendar. Now we've looked at pretty much every property of the month calendar control. You're ready to go out and display calendars on your Windows forms. The Date Time Picker control allows users to select a single date and possibly a time. You determine the format for the Date Time Picker, and it allows users to indicate a null value if you offer that option. Let's look at a simple form that demonstrates the use of the Date Time Picker control. I'll open the Date Time Picker form here and zoom it up full screen so it gets everything else out of the way. And in the upper left-hand corner is our Date Time Picker control. See, we can drop down a calendar to select a date. There we are. We can choose the format for our date. The format can be long, short, it can be just a time, Or we can choose a custom format. If we choose a custom format, we can use any of the standard .NET date formatting template symbols to format the date. Here I've chosen a 4-digit year, a 2-digit month number, so we'll get leading zeros if necessary, and a 2-digit day number, where single-digit values are preceded by a 0. You could choose any format you like. For example, I could choose, although that isn't a very meaningful value since it looks a lot like a time, you can use it to format your dates if you like. Of course, since in this case I chose lowercase m, I got minutes. I'd have to choose uppercase M to actually get the month. This template is case sensitive and you need to be careful. The .NET Framework documentation includes a chart that describes each of these custom template characters. You can select minimum and maximum dates just like we did with the month calendar control. And you can format this control as well with the same rules applied. That is, your operating system may limit the amount of functionality you can use here in changing the format of this control. Now in addition, there is the option to show the up-down. If you choose to show the up-down, let's pick a normal date format here, you can use the up-down to change any of the values in the date time picker. If we choose time, for example, we can use the up-down to change these values here. You can also show a checkbox. And this checkbox allows you to have users indicate that they don't want to supply a date or time value. When the checkbox is unchecked, that should indicate to your code that this is a null value. That is, they're not specifying a date or a time. You only show that if you want to. Normally, you don't. It's only in cases where you want to give the option of supplying a null value that you show that checkbox. Again, we could change the calendar font. Let's make it italic, say, but not bold. Now, if we don't show the up-down, I can drop down the calendar, and you'll see we have italic, but not bold, font in the calendar. You can change other features of the calendar as well, only if your operating system allows it. It's important to note that the value property gives you the value of the date time picker control. We can retrieve the time and or the date from the value. I'm displaying in my label control the date portion and the time portion formatted. If you're showing a long value, for example, I've displayed it sort of incorrectly down here, but remember, the value property of the date time picker is a real date time value, which you can then do with whatever you want. You let the user select a date time, you can then take that date time value and use it in your code.